In this video, we're going to discuss graphing sine and cosine functions. We've been discussing that sine and cosine are functions of the angles inside them. And now we're going to graph it as a function of t, the angle. So the first thing is to put in at least the familiar angles like pi 6, pi 4, pi 3, anything that you would that would come from the unit circle over here, and so on and so forth on the t line, and then find the y value for those and graph them. So the plan is to graph y equal to sine of t, the simplest form of sine and cosine. I guess the simplest form of sine. So to find, as you would do with any other function, you plot as many as you can and for the starter. So what I did over here is I went to the unit circle, started from 0, put in 0, pi 4, pi 6, pi 4, pi 3, pi half. Then I went to the second quadrant, 2 pi 3, 3 pi 4, 5 pi 6, and pi. Third quadrant, 7 pi 6, 5 pi 4, 4 pi 3, 3 pi half, and the fourth quadrant, all these values. And then what I want to do, this is again by plotting, so I want to plug in every value in the sine function. I've already done that. This is just using the first column of the table that we use. It's 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Then I do the second quadrant. Second quadrant here, sine still is positive, so I use the values that I have. The denominator here is 3, so I have to use that one, square root of 3 over 2. Denominator here is 4, square root of 2 over 2. Denominator is 6, 1/2. And then this one is the end point is going to be a 0. This one, this table is the one in the third quadrant. And in the third quadrant, everything has to be both sine and cosine are negative. Right now, I'm just discussing sine. Sine is negative, y value is negative. Therefore, whatever I find from the tables before, from the reference table, I put a negative sign in front of it. Denominator 6 gives me negative 1/2. Denominator 4 gives me negative square root of 2 over 2. Denominator 3 gives me negative square root of 3 over 2. And then the last one is going to be negative 1. Over here, this part is all in quadrant 4, and in quadrant 4 again, y is negative, so all the values are going to be negative. And on start, denominator 3 in the reference is negative square root of 3 over 2. Denominator 4 is negative square root of 2 over 2. Denominator 6 is 1/2, negative 1/2, and 2 pi becomes 0. And I know that if I go round and round the unit circle, I repeat the same process. That's why the sine function is periodic. So let's plot all these points first. And so for 0, I get 0.0. For pi 6, I get about square root of 2 is about 1.4, divided by 2 is 0.7. For pi 6, I'm sorry, I'm getting 1/2 right here. For pi 4, I'm getting square root of 2 over 2, which is about 1/7, is 1.4, I'm sorry, divided by 2. And then for pi third, I get a little higher than that because it's it's going to be the square root of 3 divided by 2, which is 1.7 divided by 2, so a little higher than that. And then pi half is going to be 1. This is supposed to be a little higher than that. And 1. And then for 2 pi third, again, I get the square root of, and for 3 pi fourths, I get square root of 2 over 2. For pi 5/4, and again, I get 1/2. For pi, I get 0. Then over here, I get the negative value. For over 6, I get negative 1/2. Then pi fourth is a little higher. Pi third is a little higher than that. Then 3 pi fourth is 1. And then symmetrically goes down. And 0. So if I connect it, it looks like this wavy. You can use other points in there also, but it looks like that. And then I know that everything is going to repeat, so I know that this is whatever I have between 0 and 2 pi would happen again between 2 pi and 4 pi. And over here, I know that this is going to happen again. Whatever I have, it goes on the other side as well. So that's the simplest form that we can have. It's y equal to sine of t. In here, interesting things to know. It seems like if I average out all the values above and below for this curve, it ends up at y equal to 0. And that's called midline. This one has midline is y equal to 0. It's actually y equal to the average of all the values of the curve. And we're using the term average loosely at this point. And then what is the amplitude? Amplitude is the highest distance you can get for the curve from the midline, and that would be at point, let's say pi half, or it would be at point negative pi half. This is the highest distance that you can get, which in this case is 1. So amplitude in this case is 1. What is the period for sine t and cosine t? The period is 2 pi. So the next part, we're going to come back and we try to do the same thing for cosine of t, and then we would discuss the all the transformations that we can do in either of the functions. So I'm going to erase the board and continue. So we're continuing with graphing y equal to cosine of t. For y equal to cosine of t, I have to get from the reference table, from the important angles reference table, I'm going to take the second column. And so 1 for 0, square root of 3 over 2 for pi sixth, and so on and so forth. This is the first quadrant. Now let's move on to the second quadrant. If you remember, x value is negative in the second quadrant, so cosine should be negative. Back to the reference, denominator 3, I should use the negative sign. Denominator 4, I should use the negative sign. Denominator 6, I should use the negative sign. Denominator, and here is going to be 1, negative 1. And then move on to the third quadrant and see how easy it becomes. It's just the method of memorization makes it really easy. Denominator 6, I have to have that. And third quadrant is a negative value, so I put in negative square root of 3 over 2. And then negative square root of 2 over 2, negative 1/2. and add 3 pi half at 0. Again, in quadrant 4, x is positive, so cosine t should be positive. Again, back to the reference table, and 1/2 square root of 2 over 2, square root of 3 over 2, and at 2 pi, it's 1. Now let's put the points, plot using these points. At 0, I get 1. Right there. At pi sixth, I get square root of 3 over 2, which is about here. Then at pi fourth, I get square root of 2 over 2. At pi third, I get 1/2. At pi half, I get 0. At 2 pi third, I get negative 1/2. At 3 pi fourth, I get negative square root of 2 over 2. And at 5 pi 6, I get negative square root of 3 over 2. At pi half, at pi, and this one is pi, not pi half. At pi, we get negative 1. At 7 pi sixth, we get square root of 3 over 2, square root of 2 over 2 for 5 pi fourth, negative 1/2. These are negative, and 0, and then we are down to our last column, 1/2. And square root of 2 over 2, square root of 3 over 2, square root of, and 1 is the last one. So it goes something like that. And that's one period between 0 and 2 pi, because we know that if we go around and around of this one, it just repeats it. So it starts from 1 rather than starting from 0 with sine of t, and it goes on. And I know that it's going to repeat the same stories between 2 pi and 4 pi. So it's going to be a wave that just goes on and on and on forever. So the other thing is, this is also like sine of t. I see that the midline is y equal to 0. And I can feel that I have not done justice to this part. It's not very symmetric. It should be symmetric when the period, the first period is done, then the rest of it is going to be symmetric also. And that one is a little higher. Again, hand drawing is not as perfect as you think. And then midline is again y equal to 0. Amplitude again from y equal to 0 to the highest point, there's just 1. Period again is 2 pi.